the quiet clanking of steel pontoons and the hum of engines. This is where our story truly begins. Not with the thunder of artillery or the charge of tanks, but with the sound that would crack the German Empire's most trusted defense. By May 1945, Germany lay in ruins. The lesson was brutally clear. Rivers had ceased to be barriers of permanence. The capacity to improvise, to construct in hours under fire what once took days, had tipped the balance decisively. Floating pontoon bridges weren't just military tools anymore. They became symbols of inevitability. They proved that no natural feature could halt armies equipped with modern engineering might. For Germans who never expected such feats possible, realization came too late. It marked the final collapse of a defensive illusion that once seemed unshakable. But how did it all begin? Let's go back to that fateful summer when everything changed. In the summer of 1944, war in Europe reached a decisive phase. The Allies advanced from Normandy's beaches. They pushed eastward across France. Meanwhile, the Red Army drove the Wehrmacht back across Eastern Europe. Yet one challenge remained constant on both fronts. Rivers. Broad, fast-flowing waterways flanked by destroyed bridges. German commanders assumed these were natural fortresses, obstacles that would slow attackers for weeks. Here in the shadow of rivers like the Seine, the Dnieper, and eventually the Rhine, an engineering race unfolded. One the Germans never anticipated losing so quickly. Rivers had always been decisive in warfare. Throughout history, commanders treated them as natural boundaries. They forced armies to pause, regroup, or fight costly battles to secure crossings. In Western Europe alone, the meandering Seine and mighty Rhine served as defensive lines for centuries. By the time the Wehrmacht retreated across France in 1944, Hitler and his generals believed those waters would buy valuable time. Time to reorganize and rebuild shattered divisions. German intelligence reported that bridging such rivers under combat conditions would take the Allies weeks, maybe months. This assumption was rooted in past wars. Wars when massive pontoon trains and slow-moving construction units were needed to span wide currents. What Germans didn't fully grasp was revolutionary. The Allied war effort had transformed military engineering into a weapon of speed and surprise. Now let's flash forward to witness the most dramatic demonstration of this new reality. The final obstacle that loomed largest in German strategic thinking was the Rhine River. Stretching across western Germany, it had long been regarded as a natural frontier. German culture and history celebrated it as a symbol of national defense. Hitler himself proclaimed that the Rhine would form an unbreachable wall against advancing allies. Bridges along its length were systematically demolished. Defenders prepared to contest any crossing. The German population, worn down by years of war, placed hope in the river. It was the last line of security before the heartland. Yet Operation Plunder, launched by the Allies in March 1945, would demonstrate conclusively that such confidence was misplaced. The Rhine crossing was meticulously prepared. Under Field Marshal Bernard Montgomery's command, British and American forces amassed enormous stockpiles of bridging material on the western bank. Entire engineer divisions were assigned to construct pontoon and Bailey bridges under fire. Deception operations misled Germans about true crossing sites. Meanwhile, American forces under General Omar Bradley and George Patton planned parallel operations further south. The crossing wouldn't be localized, but executed on a broad front. The operation began on the night of March 23rd. British and American infantry stormed across in assault boats. They were supported by one of the heaviest artillery barrages of the war. Almost immediately, engineer units moved in. They erected treadway bridges using steel pontoons. Despite fierce German resistance, the first bridge suitable for tanks was completed within hours. By dawn on March 24th, Allied armor was already moving across. Within days, multiple crossings were functioning. This included a massive pontoon structure at Wiesel. Perhaps the most dramatic episode was the capture of the Ludendorff Bridge at Remagen. Elements of the U.S. 9th Armored Division seized it on March 7th. This was weeks before plunder officially began. Against all German expectations, the bridge hadn't been fully destroyed in time. American troops seized it intact. Engineers immediately reinforced the damaged structure. They simultaneously built pontoons nearby to ensure redundancy. This surprise crossing created a bridgehead across the Rhine far earlier than German planners thought possible. It accelerated the collapse of defenses. The sheer scale of the bridging effort was unprecedented. Allies deployed hundreds of amphibious vehicles, assault boats, ferries, and floating bridge sections. They worked day and night to maintain supply lines. Smoke screens blanketed the river to obscure German artillery observers. Aircraft dominated the skies, preventing the Luftwaffe from intervening effectively. Within a week, entire Allied armies were streaming across. Tanks, trucks, artillery, and endless convoys. For German defenders, the psychological blow was devastating. Soldiers had been told the Rhine was impregnable. Now they watched enemies build pathways across its waters in record time. Reports from German officers described panic and disbelief. Some units collapsed before they could even mount counterattacks. The illusion of safety behind the river was shattered. With it went the last coherent defensive line west of Berlin. But how did the Allies achieve such impossible speed? The answer lies in a transformation that began years earlier. What Germans didn't understand was how Allied war effort had transformed military engineering into a weapon. Since the North African campaign, British and American forces learned to improvise crossings in hours rather than days. Soviet engineers, equally inventive, had been perfecting river assault since 1941. They were forced to fight across countless waterways in Ukraine and Belarus. By 1944, river crossing units in all major Allied armies carried modular bridge equipment, prefabricated pontoons and heavy ferries designed for tanks. Their doctrine had shifted from cautious construction to lightning-speed improvisation. The goal was keeping armored spearheads moving forward without pause. For Germans, this was an overlooked danger. Their defensive planning often revolved around blowing permanent bridges and fortifying riverbanks. They trusted natural waters would delay Allies long enough for reserves to arrive. But while Wehrmacht engineers excelled at demolition, they underestimated their opponents' adaptability. The Wehrmacht also suffered from shortages of fuel and transport in war's later stages. This made it difficult to contest crossings once Allies had bridged them. In effect, the very rivers they relied on as shields became traps. They cut off retreat when Allied engineers spanned them at astonishing speed. The ability of Allies to overcome rivers at speed wasn't an accident. It was the product of deliberate innovation. From war's earliest stages, British, American, and Soviet engineers understood that bridging operations would be essential to any advance into occupied Europe. By 1943, with large-scale offensives being planned, Allies had developed a wide array of bridging systems. These were designed to be transported quickly and assembled under combat conditions. Among the most famous was the Bailey Bridge, a British invention first introduced in North Africa, later deployed extensively in Italy. Its genius lay in modular design, light enough to be carried in parts by trucks, yet strong enough once assembled to support tanks weighing over 40 tons. For floating operations, engineers relied heavily on pontoon units. The United States Army invested in pneumatic pontoons. These could be inflated and linked to form floating roadways in hours. They were paired with steel treadways that allowed Sherman tanks and heavy trucks to cross swiftly once pontoons were in place. The British developed folding boats and assault rafts capable of transporting infantry across fast-moving rivers before heavier equipment could be ferried over. The Soviet Union took another approach. Its engineered troops mass-produced wooden pontoons and rafts. These were supported by extensive stocks of captured or improvised equipment. This ensured they could improvise crossings even without formal bridge-building material. The scale of Allied preparations was staggering. In the lead-up to the Normandy invasion, thousands of Bailey Bridge panels were stockpiled in southern England. American logistics officers planned not merely for one or two crossings, but for a sustained campaign across multiple rivers. Specialist units, engineer combat battalions in the U.S. Army, and Royal Engineers bridging companies in the British Army were trained specifically to deploy bridges while under artillery and machine gun fire. Soviets likewise organized entire bridge brigades. These were composed of thousands of men whose only task was erecting crossings under battlefield conditions. One of the most critical breakthroughs was coordination between infantry, armor, and engineers. Rather than viewing bridge construction as a separate task, Allied planners integrated it into operational timetables. This meant advancing divisions would arrive at rivers already expecting crossings to be prepared within hours. Tanks were held back only briefly, while engineers rushed pontoons into place under covering fire. The effect was keeping momentum unbroken, denying Germans the pause they desperately needed to reorganize their lines. Another innovation was amphibious vehicles. The American-built DUKW, a six-wheeled truck capable of driving on land and floating on water, proved invaluable in early stages of river crossings. Thousands of these ducks were deployed across Europe. They ferried troops and supplies over rivers before permanent bridges were established. Combined with mobile cranes, bulldozers, and other heavy machinery, they created a mobile toolkit of engineering capabilities that the Wehrmacht couldn't match. The transformation of river crossings into swift, decisive maneuvers depended not only on new equipment, but also on rigorous training of specialized units. By the time Allies landed in Normandy, entire battalions had been drilled for months to execute complex bridging operations under pressure. In the U.S. Army, engineer combat battalions carried out exercises in England that simulated night crossings under live fire. Smoke screens were laid down to obscure movement. Aircraft provided cover overhead. British Royal Engineers likewise conducted repeated drills along the Thames and in training grounds across southern England. They rehearsed assembling Bailey bridges in record time. What distinguished these preparations was emphasis on speed. Military manuals stressed that delays at river lines could unravel entire offensives. Engineers were trained to work in conditions mirroring battlefields. Darkness, mud, enemy fire, and chaotic coordination with armored columns waiting impatiently on the opposite bank. Soldiers became adept at handling heavy steel panels, inflatable pontoons, and assault boats with remarkable efficiency. Accounts from the period described engineers assembling spans in just a few hours, spans that only a generation earlier would have taken days. Soviets operating on the Eastern Front, where rivers were broader and conditions often harsher, adopted even more brutal training regimens. Red Army sappers drilled in storm boats, camouflage techniques, and rapid raft building using locally available timber. They learned to ferry not just infantry, but entire artillery batteries across rivers like the Dnieper. Soviet commanders expected their engineers to perform while under direct threat of Luftwaffe air raids and German artillery barrages. This pushed their endurance to limits. By winter of 1943 to 1944, Soviet bridging brigades had acquired a reputation for their ability to improvise under conditions that would have paralyzed most armies. A crucial element of preparation lay in logistics. Building a pontoon bridge required immense quantities of material, tons of steel, timber, rubber pontoons, and heavy vehicles for transport. The U.S. Army alone shipped thousands of tons of bridging equipment across the Atlantic in advance of the European campaign. In some cases, entire convoys were dedicated to carrying Bailey Bridge components. These could be offloaded at ports and moved inland on trucks. By summer 1944, Allied armies advancing through France had mobile stockpiles of bridging material ready to be deployed at a moment's notice. Coordination between different branches of military was another decisive factor. Air superiority, which Allies had achieved by mid-1944, allowed bridging units to operate without constant threat of air attack that had plagued earlier campaigns. Smoke generators were deployed to shield bridge-building operations from German artillery observers. Infantry units were tasked with securing bridgeheads on the far bank before engineers began construction. In many cases, tanks and self-propelled guns provided covering fire directly from riverbanks. This created a protective curtain behind which engineers could work. Germans facing these disciplined and well-equipped units were often taken aback by execution speed. Reports from Wehrmacht officers describe astonishment at seeing entire armored formations cross bridges that seemed to appear overnight. This rapid tempo was the result of relentless training, integrated planning, and recognition that rivers could no longer be treated as passive defensive lines. By war's latter part, Allied armies had transformed bridging from an obstacle into a demonstration of technological and organizational superiority. Now, let's witness the first shocking demonstration of this new reality. The first real demonstration of Allied bridging speed that truly shocked German command came during the dramatic pursuit across France in August 1944. After breaking out of Normandy during Operation Cobra, Allied armies surged eastward at unexpected pace. German defensive strategy hinged on slowing this momentum by falling back behind the Seine River. They believed its breadth and destroyed bridges would stall the enemy for weeks. The Wehrmacht demolished crossing points near Paris, Rouen, and Mantes. They expected advancing Anglo-American forces to be halted long enough for reinforcements to establish a defensive line further east. Instead, the opposite occurred. Within days of reaching the Seine, Allied engineer units were already deploying pontoons and Bailey bridges under combat conditions. At Vernon, British forces conducted a daring assault crossing between August 25th and 27th. They ferried infantry across in storm boats before engineers erected a temporary bridge for armor. Despite heavy German resistance, the bridgehead was quickly secured. Tanks of the Guards Armored Division rolled across within 48 hours. The speed of this crossing stunned German defenders. They had been assured by commanders that the river would hold back the British for at least a fortnight. On the American sector, the pattern repeated itself. At Mont-Gassicourt, elements of the U.S. 19 Corps crossed the Seine on August 19th using assault boats. Bridging battalions erected a heavy pontoon bridge soon after. Within less than 2 days, American armor was crossing en masse. They drove deep into German positions. Another crossing at Melun allowed Patton's Third Army to exploit the breach, pushing rapidly toward the Moselle. In total, Allied armies established multiple bridgeheads across the Seine in a matter of days. This created a shock wave that reverberated through German command structures. The speed of these operations had a devastating psychological effect. German intelligence officers reported to Berlin that Allied forces appeared to be ignoring natural obstacles. This was an admission that long-held faith in rivers as defensive barriers was collapsing. Many German units retreating from Normandy found themselves unable to regroup. The Allies were across the Seine before their formations could reorganize. Survivors recalled chaos of trying to retreat eastward, only to discover that Allied tanks were already moving beyond the river line. From the logistical standpoint, the Seine crossings demonstrated how Allied planning had achieved near-industrial efficiency. Entire convoys of bridging material moved behind spearheads, ensuring equipment was always available. Pontoon bridge sections were brought forward in synchronized waves. Bailey Bridge components followed by truck convoys. Each crossing was less a singular feat of improvisation and more the execution of a well-rehearsed system. A system perfected since North Africa. For German defenders, the Seine episode marked a turning point in their perception of the enemy. The myth of delay behind rivers evaporated in less than a week. Officers who had once confidently asserted that French rivers would provide natural lines of defense were forced to confront grim reality. Allied mobility, supported by rapid engineering, meant that even major waterways couldn't guarantee respite. From this moment on, each successive retreat eastward carried a sense of futility. German troops realized that the enemy's ability to span rivers in hours had rendered one of their most trusted defensive strategies obsolete. But the Eastern Front would witness even more spectacular demonstrations of engineering prowess. While Seine crossings shocked German commanders in the West, it was on the Eastern Front that the true scale of engineering innovation came into view. The Red Army, advancing steadily from 1943 onward, faced some of Europe's largest rivers: the Dnieper, the Vistula, and finally, the Oder. These waterways weren't narrow channels, but immense obstacles, often several kilometers wide with marshy banks and fast currents. German planners expected them to halt Soviet offensives for months, especially given widespread destruction of permanent bridges. Yet Soviet engineers, hardened by years of retreat and recovery, had mastered the art of overcoming these formidable barriers with ruthless efficiency. The most famous example came during the Dnieper offensive in autumn 1943. After liberation of Kiev was ordered, Soviet forces launched what became known as the Battle of the Dnieper, one of the largest river crossing operations in history. Entire armies were ferried across in storm boats, makeshift rafts, and even barrels tied together. Soviet sappers built pontoon bridges under constant artillery and air attack, often at night, while infantry clung to hastily assembled ferries. Despite suffering enormous casualties, the Red Army succeeded in forcing multiple bridgeheads across the river within weeks. They overwhelmed German defenses that had been proclaimed impregnable. By 1944, Soviet bridging tactics had become even more refined. During Operation Bagration in June, engineers rapidly spanned rivers such as the Berezina and the Niemen. This enabled armored spearheads to maintain momentum deep into Belarusia. German troops reported astonishment at how quickly Soviet pontoons appeared, sometimes within hours of a breakthrough. At the Vistula in January 1945, the Red Army constructed bridges strong enough for tanks and artillery within days. This allowed the massive offensive toward Berlin to roll forward without pause. Perhaps the most striking demonstration occurred on the Oder River in March 1945. German propaganda had hailed the Oder as the last great wall before the capital. Yet Soviet engineers, supported by artillery barrages and night operations, established bridgeheads almost immediately after reaching the river. Temporary pontoon bridges were laid down despite flooding and fierce counterattacks. Within a short period, heavy armor was rolling across, setting the stage for the final assault on Berlin. German defenders, exhausted and short of supplies, found themselves unable to exploit even this vast waterway to slow the inevitable. Soviet ingenuity extended beyond conventional bridging. Engineers frequently improvised with local materials, logs, barges, and even farm equipment repurposed for river crossings. In many instances, villagers were conscripted to assist in carrying timber or lashing rafts together. The scale of manpower available to the Red Army meant that even colossal rivers could be crossed through sheer determination and organization. German accounts described disbelief at how entire divisions seemed to materialize on the far bank overnight, despite the river that was supposed to protect them. The Eastern Front also highlighted a brutal reality. These crossings were achieved at immense human cost. Thousands of Soviet engineers and infantrymen perished in first waves, often drowning under fire or succumbing to icy waters. Yet their sacrifice enabled the relentless momentum of Soviet offensives. For the Wehrmacht, it proved that no natural barrier, no matter how wide or forbidding, could guarantee safety once the Red Army committed itself. The illusions built around the Dnieper, Vistula, and Oder collapsed in the same way as those around the Seine, eroded not by time, but by the ability to build bridges with astonishing speed. But what made German faith in rivers so tragically misplaced? The answer lies in their fundamental misunderstanding of modern warfare. When German military planners envisioned defense of the Reich, they consistently treated rivers as lines of certainty. By war's late stages, commanders along both Western and Eastern fronts placed great faith in these natural barriers. They assumed that broad currents like the Seine, the Meuse, the Oder, and most significantly the Rhine would slow enemy advance long enough to allow divisions to regroup and counterattack. This belief wasn't irrational in itself. Throughout military history, armies had depended on rivers to form defensive anchors. What made German reliance dangerous, however, was the false sense of permanence it gave them. In the face of a war that had become increasingly mechanized and mobile. In 1940, when the Wehrmacht stormed through France, they had themselves used river crossings as means of breaking enemy lines. The German military machine had then exploited the Meuse River crossing near Sedan. They employed pontoons and storm boats to outflank French defenses. Ironically, only 4 years later, German leaders failed to recognize that their enemies had learned from those very tactics and refined them on a much greater scale. The idea that rivers could serve as unassailable defensive lines persisted in German headquarters long after the nature of war had shifted against them. The Wehrmacht's defensive plans leaned heavily on demolitions. Retreating German units were ordered to destroy bridges as they fell back. They left behind ruined spans of steel and stone in hope that pursuing armies would be halted for weeks. After the Allied breakout from Normandy in August 1944, bridge demolitions became routine. In some cases, like at Rouen on the Seine, German engineers prepared elaborate charges to ensure crossings were rendered unusable. What they underestimated was the ability of Allied forces to respond almost immediately with temporary replacements, bypassing the delays they expected. Part of German overconfidence came from their own difficulties with large-scale engineering later in the war. By 1944, the German army lacked resources to maintain specialized bridging units on a large scale. Shortages of fuel and transport meant that even when German engineers could assemble pontoons or ferries, they often lacked mobility to bring them to critical points in time. Meanwhile, Allied production had flooded the battlefield with Bailey Bridge components, prefabricated pontoons, and specialized vehicles. This ensured that river crossings could be planned on a scale the Wehrmacht could no longer match. The German High Command also relied on psychological expectations. They believed that wide rivers would serve as morale-shattering obstacles for advancing troops, forcing attackers into costly frontal assaults. Propaganda within the Reich boasted that the Rhine would serve as Germany's final shield, a natural moat protecting the heartland. But as Allies advanced, these proclamations became increasingly detached from reality. Soldiers at the front, particularly those fighting in retreat across France and Poland, quickly learned that rivers no longer guaranteed safety. Many Wehrmacht veterans later recalled shock of seeing enemy tanks and trucks rolling across bridges that had been constructed seemingly overnight. The reliance on rivers as defensive guarantees revealed a deeper flaw in German military thought. The Wehrmacht was still operating within a 19th-century framework, imagining that nature itself could provide time and security in face of modern logistics. In truth, rivers became less a shield than a test of adaptability. By late 1944, it was the Allies, American, British, and Soviet, who had mastered the art of turning those tests into triumphs. By 1944, the contrast between German and Allied engineering resources had become striking. The Wehrmacht had once pioneered bold river operations, but its bridging units had been whittled away by attrition and shortages. Allies, in contrast, had transformed engineering into an industrial-scale arm of warfare, treating rivers not as barriers, but as predictable challenges to be solved. For German commanders clinging to their faith in natural defenses, the stage was set for an unpleasant discovery. Rivers no longer promised safety, only the opportunity for Allies to showcase their ingenuity. By the closing weeks of war in Europe, the myth of rivers as shields had disintegrated entirely. From the Seine to the Oder, the speed and precision of Allied bridging operations had revealed a profound transformation in modern warfare. Engineering had become a decisive arm equal in importance to infantry, armor, and artillery. German commanders, who had once planned entire campaigns around the expectation that waterways would buy them weeks of time, now found themselves outmaneuvered and outpaced at every turn. The rapid construction of floating pontoon bridges exposed the vulnerability of static defenses in a world where mobility and industrial production dictated the outcome of battles. One of the most striking consequences of this collapse was the paralysis of German retreat. On both Western and Eastern fronts, Wehrmacht units discovered that their fallback lines, carefully selected along rivers, offered no true respite. Instead, they often became death traps. Entire divisions retreating in the belief that a river would cover their withdrawal were overtaken when Allied engineers spanned the obstacle overnight. At the Seine, thousands of German troops were cut off and captured. On the Vistula and Oder, retreating formations found themselves encircled as Red Army bridging units established crossings faster than expected. What had been envisioned as safety became isolation. The collapse of this illusion also carried enormous psychological weight. German soldiers who once believed propaganda promising that rivers like the Rhine or Oder were insurmountable barriers now witnessed tanks rolling over newly built pontoon spans within hours of their arrival. Prisoner interrogations conducted by Allied intelligence in 1944 and 1945 repeatedly highlighted disbelief among captured troops. Many admitted they had been ordered to hold positions only until rivers could guarantee protection, a guarantee that dissolved in face of Allied bridging. This loss of faith undermined morale and hastened desertions. Beyond the battlefield, the engineering feats carried political and symbolic resonance. The Rhine, long celebrated as a cornerstone of German identity, was crossed in force not once, but multiple times in spring 1945. The rapid Allied bridging operations symbolized the collapse of Hitler's promises and the failure of his defensive strategy. For Soviets, storming the Oder and pushing pontoons toward Berlin carried an equally powerful message. The Reich's heartland was no longer shielded by nature. The propaganda value of these crossings was immense. They demonstrated to soldiers and civilians alike that nothing could prevent the inevitable. Historians later recognized that the bridging operations were as much a triumph of industrial capacity as of tactical brilliance. Allied forces could deploy thousands of trucks, workshops, and prefabricated components. This ensured that any destroyed bridge could be replaced in record time. Germans, starved of resources and crippled by constant shortages, couldn't replicate this feat. Their reliance on natural obstacles revealed not only a misreading of modern warfare, but also their inability to compete in the industrial race that defined the conflict. Operation Plunder and the events at Remagen proved beyond doubt that the age of natural barriers had ended. The ability to erect floating pontoon bridges in mere hours transformed the strategic landscape. It made even Europe's most formidable rivers obstacles only in theory. In practice, Allied engineering turned them into little more than temporary inconveniences. The German expectation that the Rhine would hold back Allied advance dissolved almost instantly. This paved the way for the final push into the Ruhr and ultimately the capital itself. Floating pontoon bridges weren't just military tools. They became symbols of inevitability, proving that no natural feature could halt the advance of armies equipped with the full might of modern engineering. For Germans who had never expected such feats to be possible, the realization came too late. It marked the final collapse of a defensive illusion that had once seemed unshakable. And so, in those final weeks of spring 1945, as the Third Reich crumbled, the quiet clanking of steel pontoons continued. The hum of engines persisted. Not as the beginning of our story now, but as its inevitable end. The age of rivers as shields was over. The age of engineering as conquest had begun.